Hello guys, this is the new video for differential equations, and in that video I will talk about the exact differential equation. So what is actually the exact differential equation? Examiner will give you this kind of format. Be careful, remember this format. It is also the format of non-exact. But how can you understand like the given equation is an exact differential equation, not a like non-exact differential equation? You have to do this test. Point to be noted, this is m and m is multiplied with dx. Sometimes examiner will try to confuse you and he or she will give you dy at the first and dx at the second. In that case, don't be confused, just you need to remember this formula. M is the multiplied term, which m is multiplied with dx actually, and n is multiplied with dy. Very nice. Now how can we solve this kind of differential equation? We just have to integrate both sides and just have to add a constant, which is nothing but what? Indefinite integral constant at the left side or at the right side, doesn't matter actually. So however, in that case the integration part is a little bit tricky part. So however, let's talk about another example so that you can easily understand. So this is the question, and now I'm going to solve this question. So it is an exact or it is a non-exact differential equation. First we need to understand, for a non-exact we need to use a different kind of approach. So however, so first we need to talk about the m. So this is the m, and how I can understand this is the m? Because m is multiplied with dx and this is the n, and n is multiplied with dy. So first I have to differentiate m with respect to y, and this is partial differentiation, be careful. So this will be like e to the power y plus 1, sorry, the plus 1 will be 0 actually. Basically it is like e to the power y into cos x plus e to the only cos x. So cos x will be 0 because x will not change, x will be constant when we are differentiating something with respect to y, because it is a partial differentiation. So this is 0, right? So however, and on the other side I am doing this differentiation of n with respect to x. This is also a kind of partial differentiation. Now e to the power y will be treated as constant and sin x will become cos x. So yes, we can say something like del m by del y is equals to del n by del x. So yes, we can say this is an exact differential equation. Now we can solve using our basic method. So how we can solve? Let me change the color so that you can easily understand. First you need to integrate both sides. So this is ey plus 1 cos x dx plus integration of e to the power y sin x dy is equals to c. Now you can't solve this integration by a simple method like this is e to the power y and you are solving like differentiation of cos x, because this is dx, so we have to not differentiate actually, we have to integrate with respect to x only, and y will be treated as constant. But my friend, this is not a partial differentiation or integration. Partial in partial integration you can use it, but it is not a partial integration, it is a normal integration. So ey will not be treated as constant, or any kind of function of y will not be treated as constant. You need to do something more. So however, in that case the first thing you need to do, which is separate the functions. Like this is how we can separate, because like this is ey cos x dx, very nice integration. Separate in the sense you have to separate these things if you will get such kind of things. First you have to separate these things. I'm just telling you the approach of solving this kind of integration. Well, this is ey, this is sin x dy is equals to c. Hopefully it is visible to you. I am saying you have to separate these functions with dx and with the dy so that you can easily solve it without any hesitation. Now in that case fx will be cos x, right? So in that case we can say fx will be cos x. So this is cos x, and fy is nothing. There is nothing with without x in y. There's a function ey which is multiplied with sin x, which is a function of x. So we can't get a function of y. So this will be 0. So this will be what? 0. This will be 0. So it is now easy. Now basically you have to understand the uv pair. In multiple cases you will see this is uv pair. D of uv you have to find what is the value of u, what is the value of v. You have to find out, then we can easily solve the integration. So wait, now basically in that case we can say this is ey cos x dx plus integration of ey sin x dy plus, now this is very easy, this is nothing but what? Sin x, right? This is sin x is equals to c. Now we can easily solve it. How? We need to find out the uv pair. Uv pair means u dv plus what? V du, which is nothing but d of u into v, right? We know this formula, right? So we are using this formula now. So basically in that case you have to do a random approach and you have to consider a function so that you can easily get it. So in that case, if I am taking u is equals to ey and v is equals to cos x, then what will happen? Let's see. What will happen? Let's see. E to the power y, differentiation of cos x is sin x with a minus, plus e to the power y with a dx, sorry, dx, wait, with a minus and dx plus differentiation of function of y, which is nothing but e to the y, which is ey cos x dy. Is it looking like very much same with that? I guess there's a minus, right? So we have to take this function first, something like we have to take that u is nothing but e to the y, but v is sin x. Let's see what will happen. I'm erasing that thing because this is not correct. Now after solving some amount of question, you will see like you will be able to do it just after watching the equation. You have to practice, otherwise it is not possible to do it just in like 2 or 3 seconds. So however, in that case, after watching this question, I am able to do it just in 2 or 3 seconds because I know how to approach it. And after doing a large amount of factors or something like that, you will be able to do that. So in that case we have to take this. If I am taking uv pair is nothing but ey sin x, then differentiation of sin x is what? Cos x with a dx plus differentiation of ey is ey, this is sin x, and this is dy, right? Now integrate whole part. Now it is looking like almost same. Yes, almost same, not almost, it is 100% same. So I am now erasing again. Now I am writing the correct statement, which is nothing but what? This is the integration. This part is nothing but the integration of d of e to the power y sin y, right? Plus this is what? Sin x. Sin x is equals to c. Now differentiation of this, sorry, integration of this is what? E to the power y sin y, or not sin y, this is sin x actually. This is sin x plus, oh sorry, wait, this is again sin x is equals to c. Now this will be our final answer. So now this will be our final answer for this question. So in this video, I guess I have cleared how to solve the exact differential equation. In the next video I will talk about another example which is like a little bit hard, so that you can easily solve it. In that case you will face difficulties when you are solving this integration part. Now I want to tell you, first you need to separate the fx dx and fi dy part so that you can find out the pair easily. Pair means something like u into v. In exact differential equation, you will see the pair will be like u into v. In non-exact, you will see multiple pairs. You have to multiply something at the denominator or at the numerator, you will get something. However, basically you have to multiply a kind of integrating factors. So in the next video, not in the next video, in the upcoming videos, I will talk about the non-exact differential equation. So this is all about today's video. Thank you for watching my videos. So this is all about exact differential equations. In the next video, I will try to solve some more questions. So goodbye.